All right, everybody, welcome to the video for lesson number 10 on period and frequency. So one of the things that we learned in today's lesson was with these sinusoidal functions, we can actually shift them in a way or change them in a way where we are able to create more curves or less curves within a period of 2 pi. Looking at the period of each function, they're different as the frequency changes. So one of the basic things that we learned today was that period times frequency equals 2 pi. Now, if we go through, the first thing we want to do is figure out, well, what is the frequency? Because the frequency is going to be able to be found right from the equation of the function. So in this first one, the frequency is E. So if I know the frequency, I should be able to find the period by just multiplying period times frequency and setting it equal to 2 pi. Divide, in this case, both sides by 8, and I get a period pi over 4. For the next one, the period here is a little bit different, so the period is 2 pi over 7. In class, we talked about how the period can kind of be anything we want, so just be careful. So if we take the period of 2 pi over 7, multiply it by the period, that's equal to 2 pi. Multiply both sides by 7 over 2 pi. Those 2 pi's cancel, so the period in this case is just 7. So sometimes the period is going to be in kind of like a radian kind of measurement where pi actually represents 3.14, not 180 degrees, or it could be just a plain old number like 7. Again, notice there's a lot of extra stuff going on here which we don't really care about. So like the 5, the 3, all that stuff doesn't really matter to us. The next question gives us a frequency of 2/3. So to find the period, we have to go through and say period times 2 pi over 3 is equal to 2 pi. All right, so once we have that, we can multiply both sides by 3/2. So we'd be left with period is equal to 2's would cancel, so we'd left with 3 pi. The next question says a sine curve has a period of 2 pi over 7, determine the frequency. So if I know the period, 2 pi over 7, I can find the frequency just by multiplying both sides by 7 over 2 pi in my equation. So the frequency winds up just being 7. Again, those 2 pi's would cancel. The nice thing about leaving everything in fractions is it just makes the reducing part easier. The next question says a child on a swing will swing back and forth 30 times over a 2-minute interval. State the period and frequency of the sinusoidal function that can be used to model this child's height over t minutes. So since we're going back and forth 30 times in 2 minutes, I want to figure out how long it takes to go back and forth 1 time. So in 2 total minutes, I'm going to do 30 cycles. So I want to figure out how much time it takes to make 1 cycle. So essentially, I'm really just dividing the 2 numbers together, right? So I can say 1 cycle happens in 1 over 15 minutes. So since it says state the period and frequency, the period in this case would be 1 over 15. To find the frequency, we would multiply that by b and set it equal to 2 pi. So if we multiply both sides by 15, I get a frequency of 30 pi. The next question says write an equation of a sine function with the amplitude of 2, a period of pi over 2, and a midline of y equals -3. Period is awesome, but it's not in your equation, so you have to figure out what the frequency is. So that's my first job. Multiply both sides by 2 over pi here. So we wind up getting a frequency of 4. So this equation would be y equals 2, because that's the amplitude. Cosine, not cosine, duh, it says sine. So we'd say sine of 4x minus 3. That equation then can be graphed. So in class, we learned that if you're graphing a sine or cosine function, the first thing you want to do is graph the midline. So if I graph the midline at y equals -3, and then since the amplitude was 4, I want to go, not 4, 2, I want to go up 2, that's the maximum point, and down 2, that's the minimum point. And since the period was pi over 2, I want to go out 4 boxes and make that pi over 2. Remember, anytime we're graphing one of these, we want to go out 4 boxes because every sine or cosine curve kind of gets divided into 4 equal parts. Now, sine curves, remember, always start at the midline. They're going to go up after 90 degrees, back down after 90 degrees, and then back all the way down to the minimum after another 90 degrees. So after 270 degrees, we're going to see the full rotation back at 360. So we'll see the sine curve kind of just flows that way. Keep in mind it is a curve, it's not a lined graph, so everything should be curved in some way. Try might not make things points or valleys. So that would be one cycle of your curve. That's all you have to do and you're done. Hopefully this video helps, and best of luck on your quiz on Friday.